sir.
Very. So now it is OSI model. Open System Interconnect. OSI model is a kind of network model only. We have a lot of different networking models are there. TCP IP model, Apple Tag, IPX, SPX, novel network. So different networking models are there. Okay. So, but this OSI model is a reference model. Different organizations use different networking models. We are all using TCP IP model only. We are all using TCP IP model, not OSI model. We are using TCP IP model. Then what is this OSI model? So OSI model collect all the different networking models combined and created a new reference model. Means irrespective of its open system. Means any vendor, any kind of addressing type or any kind of device it is, this OSI model will help you to understand your network. In our organizations, network is a TCP IP network is there. I want to understand how this network is connected, how it is communicating, and how to troubleshoot this network related issues, how to maintain this network. So I can able to understand, maintain, and troubleshoot this network related things with the help of OSI model. So that's why we should learn OSI because it helps you to understand network communication, network connectivities, to maintain the network and troubleshooting networking issues. We should understand OSI model. It's a reference model. No organization use direct OSI model. OSI model is a vendor neutral. It's not about this specific company, like it's not a Microsoft related, it's not related to Linux or any IBM related. Okay, any company, any organizations, any operating system, any hardware, any network connection, any logical address, anything, it's open to everything. Anything it is, we can specify here, means anything we can use it. Okay, this OSI model contains 7 layers. OSI model contains 7 layers. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Here is the point is, the layer numbers are different. The layer number 1 is a physical layer, layer number 2 is a data link layer, layer 3 is network layer, layer 4 is transport layer, layer 5 is session layer, layer 6 is a presentation layer, layer 7 is a application layer. Some people in their academics, or maybe they learn the networking outside of your academics, any place. When you're learning, some people learn the OSI models. In case you learn already you have gone through the OSI model. Maybe you learn from application to physical layer. Some people learn from physical layer to application layer. They got confused which way we have to tell. Both are correct only, guys. 1 to 7 or 7 to 1. Top to bottom or bottom to top. Anything is same. My point is, if you are habituated already, which one you are habituated? If you ask now what is the OSI model, tell me all the 7 layers names. If you remember from application, presentation, session, transport, network, data link, and physical, good. Keep it like that now. Or if you remember like this, physical layer, data link layer, network, transport, and session and presentation application, keep it like that only. No problem. If you don't know OSI model earlier, or you don't remember, you are not sure which way you are remember also, then remember like application, presentation, session, transport, network, data link, and physical layer. Okay. The layer number wise, it is always same. Layer 1 is physical layer, layer 2 is data link layer, layer 3 is network, layer 4 is transport, layer 5 is session, layer 6 is presentation, layer 7 is application layer. Okay, these are the server layers. Layer 4, that's a transport layer, is called a heart of OSI model, provide end-to-end connectivities. This application presentation session layers are top layers, software layers. Okay, the bottom layers, network, data link, physical layer are a bottom layer, are hardware layers, and commonly people are calling. When we discussed about networking devices, hub layer 1 device, switch layer 2 device, router layer 3 device. Okay, so that's the things. Okay, guys. So what is the OSI model? Open System Interconnect. It is a reference model, a networking model. With the help of OSI model means with the help of understanding of OSI model, we can understand network and maintain the network and troubleshoot network related issues also. And OSI model contains 7 layers. This model is standardized by ISO, International Organization for Standardization. And of course, it is a reference model. Its meaning is no one will use OSI. With the help of OSI, we can understand different networking models. Okay, we are all using TCP/IP model only. In OSI model, we have 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So which way you can able to remember, that is up to you. Even you can follow the certain shortcuts to remember the layer names. Also you can try it. But my method is very simple, guys. Repeat multiple times yourself with looking at the document or without seeing it also. Okay, multiple times you repeat, you write, you tell to others, then definitely will remember. Even as same example here also. 7 layers. When we are learned that time when we are going for an interview, we may not able to recollect one of the, at least one we will forget definitely. Okay. So by practicing, it's become a hobby. Okay. It's become a hobby. Okay. Up to here. Then we'll see one by one layer explanations. Application layer. Application layer. What is this application layer? Application. Purpose of application is so you can interact with your application to do your task. Simple example, web browser is an application. Purpose of web browser is access website. Okay, there is an application called Outlook. Outlook is a mail client application. Example, in your mobile phone, you have a Gmail app is there, na? Gmail app is there. What is the purpose of Gmail app? For mail communication. You can able to send mail, you receive mail, you can check the mails also. Same thing, that is another application is called Outlook. Using Outlook, I can able to send and receive someone's. Yeah, something fake mail. Okay. So that is a mail client applications. I have another application called Putty. What is this Putty application? For remote access. I have a remote devices are there, remote Linux machine or a remote some servers I want to connect using Telnet or SSH wise. I can able to connect it using this application. Application layer is about user interfaces. Application layer is about user interfaces, application, user side end user applications or client side application, server side application. That is a top layer. application to application. That's those endpoints will communicate finally. Okay. You open a website from your browser. Okay. You open a website from your browser. Okay. Your web request will go to the web server. That web server understand your request, process your request, and provide information. Again, that information came, it display on your screen, right? So from where you are sending request? From the web browser. You got information at your browser only. So you can able to see things in the browser. And other side means at the server side. So where is this information? At web server application. A server side, web server application is there. That process it. Final stage again. Okay. It is a final stage. Application to application stage. So where are we? We are here on this. Don't worry. So it's simple to understand. See, this is one system. This is another system. So in your application, you send request. You want something. You are sending something. You're uploading a file or anything. You're sending a mail. Anything at your application side. Who is going to receive other side and final stage, where it is processed again application final. That's it is application, where it is started, where it is completed. So application, presentation, session, transport, data link and physical when you are sending. When you are receiving, physical, data link, network, transport, session, presentation and application while receiving. So where it is started, application, where it is processed, finally reached, application. So application layer is all about user providing user interfaces, application, client side and server side application. But these applications how they will understand what kind of request, what kind of information, what kind of process, what kind of service, what kind of application has to be process your request based on the protocols. That's why we are specifying this. See, HTTPS, HTTPS. Can go to Putty. If I want to connect my remote server using SSH, specify the remote server address and protocol is SSH connectivity or Telnet connectivity. Okay, how I want to connect SSH. So at application layer, you space what application depends upon what type of communication, use that related application. First point is depends upon what type of communication, we use that related application. And we specify that the destination device addresses, authentication information. Of course, that main important is their protocol. Okay, depends upon your communication, use that related applications and the protocols or port numbers. Okay, and in both sides. So when you are sending at receiving side and also the final process is done by that application only. So as I said earlier, we are sending web requests from our web browser with HTTP protocol. In a destination side, there is a web server application process your request. Okay. From Outlook, you are sending a mail using SMTP protocol. And other side, the mail server application will process your request and provide that related information. Okay. From Putty, you're sending SSH connection request to the remote server. In remote server, that SSH server application will process your request and give you connectivity. Something like this: FTP client, FTP server. Client and server application. Application layer is about applications, user interaction, related application, and backend server side, other side of process related application. Process your request, you're sending your request and process the request. Protocols, port numbers are main important application layer. Next is presentation layer. We do not have much time, so tomorrow I will again two system communicating with OSI model. I will explain it, and troubleshooting with the help of OSI model and TCP OSI model comparisons. All these things we'll see tomorrow. We'll complete this OS. Presentation. Presentation layer, encoding, decoding. What are the data you're sending? It can be any format, right? HTML format, PDF format, document format, text format, video format, MP3, MP4 formats, anything. It convert that format into ASCII format. What are the data you are sending? That will be converted into ASCII format. When you receive, the data comes in ASCII format, it converts into the regular format. Okay. So you're sharing your pictures, JPG, PNG pictures, that will be converted into ASCII format for system understanding. And it compress the data and decompress the data. Presentation layer is about compression and decompressing the data. Presentation layer also do encrypt the data and decrypt the data. So when you are sending encryption, when you receive decryption. Okay. So presentation layer, encoding, decoding, compress, decompress, encrypt, decryption. Session layer. Out of all layer, the biggest layer is transport layer. Okay. But very important, one more is in that one is a session layer. But for session layer, very only few lines are there. What is session layer? When you are sending request, a session is created. In one tab, I open a website, right? In the tab, in the web, my browser tab, in the tab again, one session is created. So that session will be maintained till the transaction is completed. So it is create a session, maintain the session, terminate the session. Okay. So session layer is trying to maintain the session till the transaction is completed. Like you are uploading a file or downloading a file. Complete the file download, completed, transaction completed. You are go to shop and scan your QR code, type the amount, select the bank, give the UPI PIN number, amount transaction, done. Sometimes you do online payments. It shows do not refresh or press the back button or close the app. Do not close the application. Why? If you do it, the session is expires. Session will be terminated in between. Transaction may be failure or amount will be detected, but transactions can be failure possibilities there. That's it is keep maintain the session. So, next, session layer also maintain authentication and authorization. You are sending request and getting, right? When you are accessing something, so with your user ID, password. Is it yours? No. And then put them on. Finish. Okay, so authentication and authorization. So when you are doing transaction, you do authenticate username, password, key-based authentication, session-based authentication. We do it. So session layer also maintain your identity verification also. Okay, identity information. Also. Session layer. So finally, we got into the transport layer. Transport layer, what it will do, we chop the data into small pieces. In transport layer, what are the data it is from the presentation layer, okay, and the session layer, what are the data is came from application to presentation, presentation to session with the session ID. So in the transport layer, data is chopped into small pieces. The process we call it as segmenting. It chop the data into small pieces. In each piece of data, it is put in numbering and sequencing. It means it will put it numbers on the each chopped data, it's segmented data. This each segmented data is attached with TCP and UDP protocols port numbers, source and destination port numbers. For your protocols, you have a port numbers, right? Source port number, some protocols having two port numbers, some are having one port. Whatever it is, source and destination, TCP port number and UDP port numbers are attached to your segmented data. Simple to say, like you have a data is chopped pieces. This is chopped data, means segmented data. To this data, it is attached a TCP, UDP, protocols port number. What protocols? So for every communication, different protocols we use it. That protocols related port numbers. Source port number, destination port number, TCP source port number, TCP destination port number, UDP source port numbers, U destination port numbers are added. Plus segment number is added. Number of packets you are sending at this transaction, that information is also added. That is called a windowing. Window size. What is window size or windowing? So you are specifying number of packets you are sending. Okay. So total number of packets or total number of segments you are sending. So that's window size. And what is the other one is segment number. TCP, UDP protocols port numbers are added to your segmented data. This total one means TCP header means what is the TCP header? Is nothing but your window size number, segmented data number, TCP, UDP, protocols, port number, source and destination port numbers. This total combined we call it as TCP header plus segmented data. Segmented data. This total combined we call it as segment. It means from the transport layer, what are the data we are getting from the transport layer called a PDU, packet data unit. For every layer, output data of the layer is called a PDU. For example, application layer, at a time of application layer process that data. That data is a layer output data, that is PDU, packet data unit. Name is data only. Okay, little conversation. So that data is come to that PDU or data is come to the presentation layer. In presentation layer, encoding, compression, encryption. Okay, so that PDU we call it as again data only. In session layer, session ID is added, session timers also added, authentication information is also added to your data, your PDU from the presentation layer. Again, the total form of PDU we call it as data only. But in transport layer, that data is divided. So you do not have a data now. We have only part of the data. And for that part of data, which part of data it is? Okay, segmented data, segment number. Okay, total number of segments are total number of segments you are sending. And TCP, UDP protocols port numbers, source and destination port numbers also added to your segmented data, part of the data. The total one, that one we call it as segment. So from the transport layer, we got a lot of segments. The data is chopped into small pieces, means a transport layer, your data is no longer one single data. Now it is chopped data. Okay. And TCP UDP difference we have already discussed earlier only. That's why I'm doing it. So what is the PDU of transport layer is segment. Okay. That segment is sent to the network layer. So these segments are sent to the network layer. In the network layer, it is attached routed protocols and routing protocols information. Routed protocols means logical address. Of course, we know only one logical address is IP address, either IPv4 or IPv6 it is. Okay. So for your segment, for each segment in network layer, it is attached source IP, destination IP. For each segment data, each segment you're attaching source IP, destination IP to the segment. And plus routing protocols information means routing information we are adding. How to reach the destination, which interface the packet has to go outside. Okay. So the packet has to go through this interface. It has to go to the default gateway or local network. So that information is attached. Source IP, destination IP, routing information is added to your segment. That is called a packet. So network layer PDU is packet. Transport layer PDU is segment. These segments attached with the source IP, destination IP, and routing information to the then it is become is a packet. From network layer we got a packet. So we got a packet, lot of segments, so lot of packets. So this packet come to the data link layer. In data link layer, two layers are there: LLC, logical link control, another is MAC layer. So logical link control actually is a link between your upper layers and bottom hardware layers. Bottom is the hardware layers, top is other software layers, right? It's make a link between them because their understanding of way is different. This bottom is different. Another point of LLC is WAN protocols works at a LLC layer only. Means you are sending data over the WAN link. Means the WAN information is also added. Okay. These WAN protocols are PPP, point-to-point protocol, SDLCs, frame relays, MPLS, now it is SD-WANs, okay. PPPoE, okay. GPON, like these are different WAN protocols we are using, depends upon the connectivities. Okay. So very oldest one, SDLC no one is using except in Cisco, in between Cisco routers only. Okay. PPP is a open protocol. Okay. And certain organizations use frame relay. Some people are using PPP. MPLS is a multi-protocol support one. So nowadays, most of us we are using in the internet, in a WAN connections, we use MPLS. But in the different organizations, there are different types of WAN communications we are doing is we can able to manage all the multiple WANs. Means you got a regular broadband internet, organization to organization leased lines connectivities, like you use MPLS, PPP connection, PPPoE connection. Okay, everything we can able to manage in the one single window that is called SD-WANs. Okay. Yeah, don't worry. So data link layer, LLC, logical link control, which is to make a connectivity between your bottom layers to top layers, as well as WAN protocols information is also added in case you are sending data through WAN link. Okay. And very importantly, in the data link layer, first very important is MAC. In data link layer, so here a MAC address is attached. Media access control, also called as MAC address, is also called as physical address. Okay, it is represented in 12 hexadecimal number, 48-bit in size. Again, source MAC address, destination MAC address is added to your packet. Plus CRC. What is CRC? Cyclic redundancy check. Actually, CRC is an algorithm. It generates a checksum data from your data only. From your data, from your packet, okay, it generates a checksum data. CRC generate a checksum data. With the help of this checksum data, we can verify our data is correct, good, are corrupted. Okay, this combined we call it as a frame. Source MAC address, destination MAC address, packet, and CRC. This combination we call it as frame. CRC we write generally CRC, but actually to add checksum data. So when you are sending data to destination, the destination uses checksum data to verify your data. At the destination, when it is verifying your data is good, it accepts the packet. Otherwise, it will drop the packet. Okay. So what is the checksum data? At the destination, verify using CRC algorithm. With the help of the checksum data, it verify your data is good or corrupted. Your data is good, accept the packet. Data is corrupted, drop the packet. This total we call it as frame. The PDU of Datalink layer is frame. That frame is now in the physical layer. Physical layer is all about physical connectivity. Wi-Fi connectivity, LAN connectivity, or maybe it is fiber optical connectivity. So physical connectivity frame, physical layer. Okay. So this frame in the physical layer convert into bit stream. That bit stream again it is convert into signal format. Depends upon the physical connectivity. For example, use Ethernet. Means LAN ports, LAN connection we are using. Ethernet, fast Ethernet, gigabit Ethernet. So LAN type connectivity. The cable we are using UTP or STP cables. So the signal convert into electrical signal. In case you are using Wi-Fi adapter for sending and receiving data, right? Wi-Fi connectivity. So the signal convert into radio signal. Depends upon your connectivity, 2.4 gigahertz frequency signal or 5 gigahertz frequency signal. If you are connect with a fiber optical based connectivity, then the signal convert into light wave signal. So this is here OSI model. Okay. So just I told very fast or less. In general, I will take a lot of time on the OSI model, but it's keep on delaying. Yesterday, just we taken earlier break, so we postponed at some point. Okay, this is about your OSI. This is TCP and OSI model comparison, guys. So, and tomorrow we'll definitely see the source and destination OSI model based communication. Okay, TCP. We can also cover TCP and OSI comparison now. Yeah, we'll do that one. TCP IP, which we are using is TCP IP only. Okay, we are not using OSI, but we are using TCP IP, Transmission Control Protocol, Internet Protocol. This TCP IP model actually came from DoD model, Department of Defense. Okay, from Department of Defense model, they taken and build a TCP IP model. And the TCP IP model came before OSI model. Generally, people say like from OSI model, TCP IP came. No, from TCP IP OS. No. TCP IP is existed earlier than OSI model. DoD model is earlier than OSI model. So OSI model came and got all the information, put everything into one place. That's OSI. So this DoD model layers are 4 layers: application, transport, internet, network access layer. Application, transport, internet, network access layer. Okay. So this is a comparison, guys. People think it's a differences. No. It's not difference, it's a comparison. In TCP IP model, we have an application layer, transport layer, internet layer, and network access layer. And OSI model contains application, presentation, session, transport, network, data link, and physical layer. What comparison is? In the TCP IP, the work of application layer is equal to work of application, presentation, session in the OSI model. Means it looks like one layer, but it will do 3-layer duty of OSI model, application presentation session at application layer side only. Okay. TCP IP transport layer and OSI transport layer is same to same, nothing, no difference. Both are do same work only. Segmentations, numbering and sequencing, windowing, okay, TCP UDP multiplexing, okay, adding this TCP UDP source port number destination ported to your segmented data and window size information, segmented number. So that's will create a segment. Okay, from transport layer, same segment. Network and internet, same. So what are the in TCP IP or TOD model internet is? So network layer in OSI model. Okay, adding IP address, source IP destination to your segment, then it is become packet. Network access layer will do two jobs. One is data link and physical layer works. What is that? Adding source IP, destination IP to your packet plus CRC checksum data to your packet. So then it is created a frame. In physical layer, it will convert into signal. So the frame is first converted into bit stream convert into the signal. Depends upon the physical connectivity. This is, I added a point, that is, you have a LAN cards, NICs, Wi-Fi adapters. Okay, NIC cards are there. No? So as per TCP IP, as I said, it is network access layer because our LAN cards are Wi-Fi adapters. Physical connectivity they are providing plus MAC address also there. That's why I said it is network access layer. So it is both. And that we are using TCP IP. Okay. So after very long time, I've taken very less time to explain this. But tomorrow, guys, compulsory today, compulsory check OSI model, other up to from what are the networking related we discuss. So please check that one today, specifically OSI model. Either today or tomorrow before the session is started, please go through your OSI model. And when there is no session time, mainly in morning, if rounds are not taking the session, please concentrate on that communication skills. Give half an hour daily, half an hour, like that. 1.5 hour today, tomorrow morning, again 1.5 hour, again tomorrow evening, 1.5 hour for technical. This compulsory read OSI model either from my notes or from any place. Read the OSI model. Okay. So tomorrow we'll see this source to destination communication, A to B, B to A communication, and troubleshooting using OSI model. Some of the networking commands, we'll see the networking commands. With the help of ping command, how to troubleshoot network, okay, and other commands also, we'll see that one. Okay. So that's it for today, guys. Please go through once, so then you can able to recollect information. Okay. So that's it for today.